we're going to go ahead and move on to our next speaker, who is going to be Ron Creel, who will discuss dust everywhere. What can we do?
Good morning. Can you hear me?
Yep, we can hear you.
Oh, very good. Yes, continue on with what Jack and others have talked about. I'm in a good agreement with most everything. Here you see a picture of the only video we have. Charlie Duke took this video of John Young driving the rover. You see the dust being stirred up. This is what we call the Grand Prix, and that was going to be used to get mobility data due to some painting of some stripes on the side of the vehicle. I doubt that we'd ever gotten that accomplished. Next chart. Dust everywhere. Dust was a considerable challenge and potential health hazard for previous short duration Apollo missions. You've seen the video shown during the break of trying to clean with the dust brush, and I agree with Jack very definitely that dust brush, it does not work. We forced the crews in their design to spend valuable exploration time in futile housekeeping efforts. Earth tested, we did test even with Apollo 12 soil, the cleaning method using the dust brush, and it worked here on Earth. It was not successful in the moon environment. And I do seriously question whether you can ever simulate the moon environment totally. Here you see the astronaut trying to clean dust from the radiators. And also, this is Apollo 15 plot there, showing that after the first time, Dave Scott said there wasn't any dust on the cover on the radiators after the first EVA, so he didn't do any dusting. Well, after the second EVA, he did dust off the radiators, and the solar absorbance went up by a factor of 5 or 6. Next chart. I want to talk first about the static and mobile surface science equipment that was on the moon before, and then what you'll need to do for renewed Artemis missions. Disturbed dust, however, is disturbed by actions of the sun or by actions of astronauts or the landing devices, landing landers, is very much prevalent. I show here a picture, some pictures from surveyors showing a levitation of the dust, and also sunrise can evidently elevate lunar dust, which has been shown. I've been told here that the laser ranging retroreflectors on 3 of the missions have shown a degradation over time. Unfortunately, all the instruments, the other active instruments, were turned off in September of 1977. So that's the end of our data. But there is some good data. And we did have the fact on Apollo 12 that one of the astronauts did run a finger swipe across the mirror showing how much dust had accumulated on the Surveyor 3 camera. Very accurate landing, by the way. Show on the bottom part there that uncovered static and mobile radiators suffer dust coverage. Solar arrays will too. That's the Lunar Communication Relay Unit on the bottom left, and you can see how much dust was on it. The original plan was to have 2 different radiator covers, 35% and 65% coverage, and astronauts would adjust that. Well, that never worked out on the moon. Once we opened up those covers and got dust on there and couldn't remove it, then they always left the dust covers open and had never had the 35% or 65%. It was always 100% open and still ran hot. The rover over there, you see, we also had a TV camera, had to be brushed quite frequently. Jack will tell you about that. As well as on Apollo 17, in the back area, we had a surface electrical properties instrument, which had a radiator, which got dust on it. It wasn't helped out by the fact that as on Apollo 16 and on Apollo 17, unfortunately, astronauts hit a hammer inside the lip of the fender extension and popped it off, which caused more and more dust to be generated. And then Jack will tell you about the dust repair that John Young worked on overnight to take some lunar maps, lunar surface maps, and clamps, and take them back outside the lunar module and fix the rover, which did help. I have encouraged people on rovers I've evaluated in different programs here recently that you need full coverage fenders on the wheels, which to help you out. This is all related to what we call Murphy's Law. Murphy's Law says that if something can happen, something bad can happen, it will. And that's what happened on those missions, Apollo 16 and 17, that we lost fender extensions. Not judging, but it's difficult to move around and to do it. Just go to the next chart. I want to talk about potential solutions for the surface science equipment. I think you need to have remotely activated and retractable insulated dust covers for inclined solar arrays and or radiators. That assumes that separately sensors are protected with shields and with shutters and whatever you need. The inclination is can be useful to help assume that the dust would flow downward toward the surface. I show here two different kind of dust covers. The Russians did, in fact, put their Lunar rover on the moon before ours went up with the astronauts, and they had a motorized cover. Unfortunately, when they backed out of a steep crater, they deposited lunar regolith onto the radiator, and ultimately the second lunar when that happened, it only lasted 4 months. The first one lasted 11 months, and I got to ask them, hey, what happened? And they told me that story about how lunar regolith, lunar dust, had caused them to fail. And we had on rovers, we had a spring activated closure mechanism, and it only ever worked once on Apollo 15 when there wasn't dust on the radiator and it wasn't rushed. I've tried to point out there that I'd like to know more about the Chinese systems there. I do know that they used a nuclear heated system, but that's not going to be allowed. If you have the automated covers, you would reduce astronaut housekeeping time for crewed missions. And you certainly would need to have that for uncrewed missions. But it will introduce motor survival and operational reliability issues. That's the bad news. The good news is you can contribute to nuclear nighttime, the lunar nighttime cold hibernation and survival during the very, very cold 14 and a half days. Let's move on now. Next chart. Let's move on now. I'm thankful that Joel already read out the quote from Gene Sarn, poor Gene, with his picture that gets published around of him inside the lunar module with the dust all over him. And I'd like to just highlight the last sentence down there. You can be careful in cleaning up as you want to, but it just sort of inhabits every nook and cranny in the spacecraft and every pore in your skin. I've pulled out some other quotes here, which are interesting to me, that Pete Conrad said that he thought that an overgarment would be very useful. This would be a suit cover. This was not implemented. There just wasn't time to do any of this, to learn in real time about these improvements. Charlie Duke sent me a note last week that's quoted here in the middle that it verifies that they thought it was so bad when they got back inside the lunar module, they didn't take off their suits. When they got to the command module, Mattingly wouldn't let them come in until they floated a vacuum cleaner over and closed the hatch until they got cleaned up. And he believes strongly that an airlock would be mandatory for these longer missions with multiple EVAs. Also, Jack, quoting from his book, he essentially takes it beyond just being airlocks to being additional dust locks. The interior design of cabins must make for ease of cleaning or for automatic accumulation and elimination of the dust. Final chart. Next chart. Final chart. What can we do? What can we do? I strongly believe that the solution is to isolate the exploration crews from direct exposure to harmful lunar dust. This is to apply NASA's already developed isolation technologies for dust mitigation. I'm showing here a near-term solution and a far-term solution. In the near term, you can incorporate mudrooms and airlocks into your systems such that you leave the dust outside. And you also can incorporate dust covers, suit covers to mitigate the dust. The far-term solution is the elegant Johnson Space Center Chariot rover, which I got to see back several years ago. And it actually was a highlight of the 2008 inaugural parade that actually would have suits that are left outside. That's a key thing, is to leave the suits outside in the environment if you can. I am encouraged here by mention on the contractors that are developing the human landing system. One of them says he's going to have 2 airlocks for moonwalks. And another one sent me a note that says the actual requirements that we've gotten from NASA and the approaches we're taking to meet them are almost entirely focused on minimizing the harmful effects of lunar dust on Artemis crew health and safety. So I am encouraged that some people are at least aware of the problem and that we're working on it. The questions that I left here for y'all are, do you have any other suggestions for what can be done about dust? And the second question, would you travel to the moon if your good health could not be guaranteed? That's all I have.
Great, thanks so much, Ron. There are several questions in the chat window or the Q&A window. I'll just ask one quick one for you real quick. Were fenders effective at reducing accumulation of dust on the LRV and astronauts? Do you think you have the same amount of dust without the fenders?
We tested actually in the KC-135 with a vacuum chamber with dust and a wheel inside there. And that's where we wanted, people wanted to remove the fenders even before we got to go to the moon. But most definitely the fenders were very helpful. It's just that we had that bad luck, had Murphy riding with us. And on Apollo 16 and 17, the rear fender was lost. On Apollo 15, the left front fender was lost. We didn't find out until we got back from the moon and looked at pictures. So that didn't cause nearly the problem that losing the right rear fender on the Apollo 16 and 17 did. So the fenders are very definitely needed.
Okay, great. Well, thanks for that.